the first thing that I have to say is that this is inaccurate in its representation of number of white blood cells to number of red blood cells. Right? In a drop, 4.8 to 5.4, say 5 million red blood cells, and in that same drop, 5,000 to 10,000 total white blood cells. So obviously, that's inaccurate. Okay? We have there, and there granulocytes, and there, and there, and there, and there agranulocytes. Okay? And of course, erythrocytes or red blood cells. So, lymphocyte, small, lymphocyte, large. This and this and this would be a monocyte. We don't see the C shape here because the C is down that way. Okay? When I give you something in a microscope, it will be characteristic. Okay? Now we have the those were the agranulocytes. Now we have the granulocytes. Neutrophils. Okay? Obvious granules. Now I would give you something in this range or this range. Lots more segments. Now, that it is accurate in how much you would see. You would see mostly neutrophils, right? Then eosinophils, and then a basophil. And since it's less than 1%, that's appropriate, only having one there. Then we have some other things in here which we didn't discuss. Platelets. These are platelets right here. Okay? The little dots, those are platelets. Okay? Or thrombocytes. Erythrocytes, leukocytes, thrombocytes. Okay? Now, that is as opposed to this, which is a platelet plug, consisting of platelets and fibrin strands. Okay? So these platelets have become active. And the fibrinogen was activated to fibrin by thrombin. You got to know the cascade of the central pathway. Okay? You don't have to know the intrinsic pathway, you don't have to know the extrinsic pathway, except for what I said. Calcium is involved in each step. They both lead to the activation of factor 10. Okay? Intrinsic comes from activation of blood platelets. Extrinsic comes from tissue factors, damage to the walls of the blood vessel. Okay? Okay. Study those, and then I'm going to start with the slides.